Angle ABC, tell me what type of angle it is or how to find it. Angle ABC, tell me what type of angle it is or how to find it. Here we go, 29. Oh, good start today, good start. 28, it's an inscribed angle. How'd you know it was an inscribed angle? Either does that angle, but it's not inscribed. I'm going to make it difficult on you. Vertex touches the circle. Vertex touches the circle. Where's the central angle touch? Center of the circle. Okay, how do you find it? Next question, how do you find it? 17, how do you find it? No. Arc length. No. Wrong vocab. Measure of the arc and what? Okay, half of what am I going to divide by 2? Which arc up here, Teddy? AC. That's just the basic right there, inscribed angle. Questions? There are three theorems now for an inscribed angle we should know in case we need to use it in a proof. Other than the vertical angles, name 2 congruent angles in my diagram. 10 other than the vertical angles. Okay, angle D and angle F are congruent. What are you going to write in your reasons column? That's what I really want to know. I think you could identify the congruent angles up there, but what are you going to write in your reasons column? Why are D and F congruent to each other? Here we go. 8. What type of angles are they?
Inscribed angles.
Inscribed angles. Where are they drawn to?
Same chord. They intersect the
Same
same chord.
chord. What arc are they drawn to?
EG. I mean
okay.
arc. Yeah.
Yes. Inscribed angles drawn to the same arc are congruent. We're all good. That's one theorem you can use in a proof or in an algebra question too to solve it. All right, everybody stop. Go to homework. Boom. Here we go. 7. You had 18 for homework? 18 uses that theorem. Here's a new diagram right now. Name 2 angles that are congruent on my diagram right now. New diagram. Name 2 angles that are congruent other than the vertical. 26. Name 2 angles. S and T. So for this problem, hopefully you took 5x plus 4 and set it equal to 6x minus 2. That's the theorem Colin just gave us. 2 inscribed angles drawn to the same arc are congruent to each other. Solve for x, plug it back in, you got 34 for number 18. Everyone good? All right, going back. Another theorem about inscribed angles. Tell me something about angle C. What type of angle is angle C up here? And that's a diameter, by the way. There's my center of the circle. Okay? AB is a diameter. Tell me something about angle C. 16. It's a right angle. If you say it's a right angle in a proof, what would you write for your reason? That's what I'm trying to get out of you here. Here we go. 23. What type of angle is it? No. Okay. Even before I knew it was a right angle, what type of angle is angle C? In the circle. So ready? Inscribed angle. Where's it drawn to, Kate? Which is A? Okay, so inscribed angle drawn to a semicircle is what type of angle? Right angle. Okay, so that's what I would write in my reasons column. Everyone all right? You had one for it on homework. All these theorems apply right to the homework. Boom, here you go. What are you doing here in this problem here to find x? Give me an equation to set up to find x. Here we go, 21. Give me an equation to find x.
2x plus x equals
Y multiplied by 2? Where's multiplied by 2? Oh, okay, I get, or you can just set it equal to 90. Okay. What type of angle is S? The right angle? That's that theorem we just said. Inscribed angle drawn in a semicircle. See where it applies to. What's up, Sinead? No. No. It's the same exact thing. You're just multiplying both sides by 2. Same exact equation. That's fine. All good there? Last one about an inscribed angle. Where's my diagram? There it is. Give me a relationship between 2 of the angles up here. Give me a relationship. That's a quadrilateral inscribed in a circle. Quadrilateral inscribed in a circle. What do I know about it? 2 of the angles here. Any of the 2. 30. Angle A plus angle C equals 180. Same with angle D plus angle B. Opposite angles are supplementary. Okay, if the quadrilateral is inscribed, opposite angles are supplementary. Shocker! You had a homework problem. 28. That dealt with this. That's an inscribed angle. What equation can I set up here? Oh, 27. Opposite angles are supplementary. Boom, solve for x. Plug it back in to find angle z. Nice job. Questions there? Oh, I'm not done with the homework. No, no. Let's go to 16. 16, it said find angle S. 13, what type of angle is S? Inscribed, so it should be half of which arc up here? RT. Oh, boy. I don't even know it. Don't even know it. But how can I use this bad boy right here to find that arc? Let's roll 17. Darn right it is. Creates what type of arc? Semicircle, 180. So what can I do with the 180 and the 48? Subtract it. Half of, I don't know, what was that, 132? Half of 132, that's where you get your 66 from. Thank you. We good? Still not done with the homework. I got 22 here, a little proof I threw at you out of nowhere. And you're not proving them congruent, you're proving them similar. Main way to prove triangles similar in a statement's reasons proof. 21, what's my main way? Angle, angle. Name a pair of angles that you had congruent in that diagram. Name a pair. 26, name a pair. There we go. The HM, say that again? Yep. Okay, JMK, those not in either of the triangles. This is JMK right here. So I think we're going to go with LMK. Yep. Vertical angles. Good. Name another pair that are congruent. 25. Why? No. Don't use the word angles. There you go. Inscribed angles drawn in the same arc are congruent. Angle, angle. Anything I didn't go over? You want to go over? Anything else? All those problems we just went over, is there anything I didn't touch upon that you wanted to talk about? Took a while. Anything else? Inscribed angles. This is where quiz number 2 will start. Meg. 30. Angle G. This is a what right here? 4 sides. Inside a circle. What do I know about G and J? They're opposite. So the theorem says they have to be supplementary. So I take 3y plus 9 plus 4y minus 11, set it equal to $1.80. Solve for y. Plug it back in for angle G, and that's where the 93 would come from. All right. Anything else? Woo! And we still got more today, a lot more. Anything else? We're okay with inscribed angles? Feel comfortable? We all feel comfortable inscribed angles. Okay, let me quickly see what you did because you had 2 days to do it. And then we'll get on to the next piece of business for today. All right, new terminology right off the bat. Tangent line in a circle. And I know the only time we've heard the word tangent would be for SOHCAHTOA, opposite over adjacent. This is much different. What is a tangent in a circle? It's a line that intersects the circle in one spot only. Everyone see my first diagram to the left. All three of those lines are tangents because it only hits the circle in one spot. Okay? That spot where it hits has a special name. So I'm talking about point F, point C, and point B. These mathematicians are very clever. Though that point where it hits the circle is called the point of tangency. Calm it down. Point of tangency. That is the point where the tangent hits the circle. Now, my second diagram to the right, I'm proclaiming that these are not tangents, and I want you to tell me why. So let's start with PQ. Why is PQ not a tangent? Okay, hits twice. Very easy. It's got to hit once. RS doesn't hit at all. All right, now we come maybe a little controversy. TU. Okay, it's a radius, but could be a tangent too. What's the problem? Hits once. You make that into a line, what's going to happen? It's going to hit twice. Okay? It's got to be a line. And VW, that's a ray. If I extended it, it would hit twice. All right, so it's got to be a line that intersects the circle one spot. All good. All right, a little fun now. Common tangents. Common tangents. That is one tangent line I can draw that hits each circle in exactly one spot. Let me say that again. That's one line that hits each circle in exactly one spot. So see my first diagram here? I have two interlocking circles, and I'm saying there's two common tangents. I'll draw one so you know exactly what I'm talking about now. Saying one line that hits each circle in one spot. But I'm saying there's two there in the diagram. I drew one. Where's the other one? On the bottom. Yep, right here. So these are the two common tangents I have. I can't draw in any other lines that'll hit each circle one spot. All right, so now when I separate the circle, now I'm claiming there's four common tangents. Where are they? Four common tangents. Where are they? So same thing as the last diagram. I'll go top and bottom. And then where are the other two? Where are the other two I can draw in that'll hit each circle once? Going this way. And the other direction. So there are your four common tangents. All right, now I'm not going to tell you anything. Next diagram, they're just touching. How many are we predicting here? I hear a 2 and I hear a 3. Well, I got one on the top and bottom, definitely, right? And where's the other one? If there is a third one. Right where those two touch. Yep. There you go. 3. What about this next diagram where I have one inside the other and they're just touching? One common tangent. Whoa, I got a quick question before we move on. I got 1 common, I got 2 common, I got 3, I got 4. There's never going to be 5, but could I get 0? Where no matter where I draw the line, it's never going to touch each circle one spot. Well, we use our big boy, big girl term. We talked about these type of circles. Concentric circles, yes. There you go. I cannot draw a line right now that intersect both of them in one spot. Okay, so that would have no common tangents. All right? Questions? All right. There are some facts about tangents that you're going to have to know. What I'd like you to do first is you got some room right around here, right below the box somewhere. You guys have some room, or in the top. It doesn't, you can draw this right here. You can draw it up top here, wherever you want to put it. I need a circle, please. I need a circle. Wherever you want to draw it. I need you to put a center in your circle and label the center, please, with a letter. Please draw on your own tangent line right now. Please draw on your own tangent line. There's infinite you could draw in, so just draw on one, please. Mark your point of tangency. Mark the point of tangency. Label it as well. Here's your first fact about a tangent. Connect the center and the point of tangency. What are you making right now? That's another name for what? Center to the point of tangency. What did you just draw in? A radius. So here's the deal. If you draw in a radius to the point of tangency, take a look at the theorem. They are perpendicular. So what's being formed here? Right angles right here and right here. Okay, so that's your first theorem for today is, hey, if you draw a radius to a point of tangency, it's perpendicular. All good. Let's apply it. If you don't have them out already, you might need some calcs out here. Okay, let's go. Look at example 1. I need to find angle X. Anything you can add to the diagram. This whole circle unit. Anything you want to try to add to this diagram. 26. Anything you want to add to the diagram. Right angle where the radius and the point of tangency meet. I got a right angle. Now using just your geometry knowledge now, where you want to go from here? 28. I do want to find X, yes. Could you lead us to that path, Liz? That's what I meant. And subtract it all from 180, yes. 180 minus 90 minus 58. 180 degrees in every triangle. X will be, what we got there? 32 degrees, yep. Whew, that was tough. Let's see how you feel after this one. 2. AB is tangent in every diagram. 7. Anything you want to add to this diagram? Where? Yes, a right angle right here, radius. Ooh, now what can I use to find? Now I'm not looking for an angle. I'm looking for sides here. What can I use? 27. Pythag. Didn't sound too confident, but it is correct. All right, help me fill it in here. Whew, 18, name a leg. 8. You got another leg. X. Here's the big one. Do we have a hypotenuse? What is it? 2 plus x or x plus 2? How do I write that in Pythag? Parentheses, x plus 2 squared. Without a doubt, you cannot leave geometry and go to algebra 2 next year without knowing what is the deal here. Because it's not x squared plus 4. It's x plus 2 times x plus 2, and you need to double distribute there. All right. So go right ahead. (64 plus x squared equals Let me know what you end up with there when you're ready. 20 when you're ready. Got it. What's going to happen here? When I start moving things to the left and the right, what's going to happen? Anybody see? X squareds are going to be gone. Okay, so hopefully some of you are taking a breath now. Whew, I don't have to factor. Yes, the X squareds will cancel out eventually, so this is what I'll be left with. And then you guys can go from there now and find the value of X. And let me know. Whoa, 30. There we go. 15. Nice. Thanks, Paige. We all good. Don't go ahead because I'm not going to do the last one there. I'm only going to do 3. We're not going to do 4 together. I'm going to save that for another time. We just don't have the time today. All right, number 3. Add something to the diagram. Here you go. 14. Want to add something? Where? CBA is a right angle. So once again, we're going to use a little Pythagorean theorem. This might be a little tougher here. Oh, 8. Give me a leg here. X squared plus, here we go. CB is the other leg, Colin, but it's not labeled. Do you know how long it is?
3.
Why is it also 3?
Because 3 is the length of the radius.
Radius length is 3. Any radius length in the circle C will be 3. Nice job. And finally, not off the hook yet, how about the hypotenuse length? 10. Everyone all right where that 3 especially is coming from there? What is going on? Questions here before we solve it. Where the 3 came from, where the 10 came from. X squared plus 9 equals 100. Please don't tell me x squared equals 81. That's not how you subtract 109. 91. Why do I feel like there's a little confusion here? Or are you just waiting for my directions at the end? Just leave it as the square root of 91. You can't break it down, and I don't want to see decimals, so that's it. All right, we'll save 4 for another time because we need to get to our little proof here. Yep, anytime we could fit one in, let's do this. I got tangent lines here. I need to prove BA congruent to BC. Hey, we're not going to do that until we prove what? Triangles. Let's get to it. Let's get to it. Prove the triangles congruent. Any circle facts we've talked about you want to use here to get those 2 triangles congruent. 11. What do you got for me? Oh, garbage. 5. Anything here? Ooh, you went hardcore right away. I like it. I got angle BAO and angle BCO are right angles. All right, here's what we're going to put. How did we know they were right angles? What are AB and BC? AB and BC are tangents, and what are OA and OC? Radii, right? So here's the theorem. You can complain after we write it, all right? It's so long, all right? Complain after we write it. All right, a radius drawn to, where's it drawn to? Name point A and point B. A radius drawn to the point of tangency. Forms a right angle. I think it's that bad, but what can we shorthand? Nothing. Is there a simple? Nope. My wrist doesn't care. Anything else I missed? No. All right, next. Thanks, Ella. What else up here? Any sides? Anything else you know are congruent to get the triangles? Let's go 13.
AO and OC.
They are. AO congruent to OC. We have gone over this theorem. What would the theorem be here? In a circle, what do we know? Radii are congruent. Nice. You guys going the hardcore way right away, not taking the easy step right away. Somebody will now, though. 30. Don't say it. I'm saving you the embarrassment, Paige. I'm saving you the embarrassment. Don't say it, because we don't need to do that.
Okay, BO is congruent to BO.
Yep.
Whoa. Oh, I see.
Let's look at our diagram right now. Side angle side up there? Is this side angle side? No, because the right angles aren't in between. Don't even think about saying side angle. You can leave the room immediately. That's never a way to prove triangles congruent. But it's still possible. You always forget about it. What is it, Connor? Hypotenuse, which is the reflexive side. The radii are the legs. This is HL. This is why I told Paige to zip it, because in an HL proof, do you need to tell me the right angles are congruent? No, you don't need to. So I just saved a step there. But you do need to tell me what before I write down the letters H and L. Triangles are right triangles. Yep. So triangle AOB and triangle, what do I got? AOB, BOC are right triangles. Anybody remember that reason back in the day? Right triangles have right angles. Right angles. And then you can tell me they're congruent, and then the sides are equal. So triangle AOB congruent to triangle BOC, HL, and then CPCTC. BA congruent to BC. Okay, I just didn't do that proof just because I wanted to do a proof with you, or because it was HL. You guys just proved your second circle theorem for today. All right, you just proved your second circle theorem, which is the following. What are AB and CB? What were they? Okay, so here's how this new theorem starts, if you want to write it up here. Tangents. Notice they're both drawn to what? The same point, all right? Tangents drawn to the same point, what'd you just find out? Are equal congruent. Okay, so if I have two tangents drawn to the same point, they are equal. A lot of people remember it this way, and you can never write this in your reasons column. People call this the party hat theorem. Crickets. No, you can't write the party hat theorem. You're writing tangents drawn to the same point are congruent. No, it's the party hat theorem. That's what people remember, how they remember it anyway. Okay? Okay, forget I ever said it. Sorry. All right. Ice cream cone, fine, whatever. Float your boat. Even though I think the ice cream is going to fall out, but. Here's where I would use that theorem right now. Okay, now the circle's inscribed. I want to know the perimeter of this bad boy. Perimeter, all sides added up. We already know one side, which is 7. How can we find the remaining 2 sides there? We're going to use the theorem you guys just proved by doing the HL proof. Ready? Everyone see this little segment is 3. Everyone see, ready? These 2 tangents are drawn to the same point. So if this piece is 3, this one right here is also 3. Tangents drawn to the same point are congruent. So now another side is 8. Help me find the third side. Ready? Up top, 2 tangents drawn to the same point. If that's 4, other tangent will be 4. And then what about this segment right here? 5, yep. So the other one would be 9 for a total perimeter of, oh boy, how about 24 centimeters? Yeah, about that. About that. All right, see what you in your group can do for 6. Because I already gave you 2 sides already. And that other missing piece is not 6. That you're not following the theorem. 2 tangents drawn to the same point are equal. (28 inches). 28. So we see where this new theorem will be applied. All right, I am going to just let you and your group do 7 and 8. It could use any circle facts we've used this unit yet. All right, any circle facts. There are no rounding directions because none are needed. See if you can add anything to the diagram. Can you add anything to the diagram? Knowing a ton of facts here. Talk it over. You can do it. Don't overthink it. Don't overthink it. You shouldn't need any formulas here. Shouldn't need any formulas. What are both of these? So what do you know if they're all in the same circle? What do you know about those 2 radii? Okay, what type of triangle now? Okay, let's go to work. How we doing here, guys? All right. Right. Same thing in here too, right? Right angle, right angle. This is how many sides? How many degrees in a four-sided figure? Okay. Let's go to work with X. Good. Okay, you guys have your tangent homework. It's not too much, it looks like. All right. Go back to reviewing on Monday. Next Thursday, quiz 2.